We're going to talk about rules for exponents now. What you can see here is what we expect you to know basic about exponents and their bases. If you have a number like 2 to the third, the 2 is called the base, and the exponent is the little number up to the right-hand corner. So 2 to the third power means 2 times 2 times 2, which equals 8. So that is something you may have learned in 6th or 7th grade. Now, in 8th grade, we introduce some other concepts. And the first rule they talked about was what is a zero exponent. 2 to the 0 equals 1. Any number to the 0 power equals 1. So whenever you have a number or a letter like a to the 0, it always equals 1. The second rule is negative exponents. So if you had 2 to the negative third power, this means the reciprocal 1 over 2 to the third, which can simplify to 1/8. So the rule they have you learn is that any base to the negative x power equals the reciprocal, or 1 over, in this case, a to the first. The next rule we learned is that when you multiply 2 to the third times 2 to the second, if you count up all the 2's, you get 1, 2, 3, 4, 5, so that equals 2 to the fifth. So what do you do with the 2 and the 3 to get 5? You add them. So 2 to the third times 2 to the second equals 2 to the 3 plus 2, or 2 to the fifth power. The way they write this rule is a to the m times a to the n is equal to a to the m plus n, where a is the same base. The next rule we're going to learn is division. If you had 2 to the fifth divided by 2 to the third, you would write it out as 5 2's divided by 3 2's, and you can make names for 1. So what you have left is 2 to the second. A shorter way to do that is to realize that when you divide, you subtract your exponents. So 2 to the fifth divided by 2 to the third equals 2 to the 5 minus 3, or 2 to the second. The way they write that rule is a to the m over a to the n equals a to the m minus n. Today we learned one more rule. That's the fifth rule. When you have something to a power, so 2 to the third to the fourth power means I'm going to write 2 to the third 4 times. Now I'm multiplying, and I remember when I multiply, I add my exponents. So 3 plus 3 plus 3 plus 3 is 12. Now, to make that a shortcut, 2 to the fourth, third to the fourth power equals 12. You can see that you multiply 3 times 4, and that equals 12. So if I gave you x to the second to the fifth power, you do x to the 2 times 5, or x to the 10th power. So when you multiply power to a power, and you write it like this, a to the m to the nth power, it means you multiply m times n. Now let's do a couple problems that have these in them. Alright, suppose you have 3 to the second times 2 to the negative third, and I ask you to simplify that. The first thing you do is identify any negative exponents, because that requires you to do the reciprocal. So when I would rewrite this, the 3 to the second would stay on top, and the 2 to the negative third would go down to the denominator and become 2 to the third. Now I can simplify that. 3 squared is 9, and 2 cubed is 8. So my answer is 9 over 8. Let's do another one. Suppose you have 3x to the fourth y to the negative fifth, z to the negative third. And I ask you to write that without negative exponents. Well, if I look at this, first of all, there's no exponent on the 3, so I put a 1 there. Just to remind myself it's 3 to the first power, it's not negative. So I'm going to identify all my negative exponents, and that means I would be doing the reciprocal of those. So when I rewrite it, these two go down, the others stay in the numerator. So I have 3x to the fourth over y to the fifth, z to the third. And that is my simplified answer without negative exponents. Okay, let's do something where we have to multiply. Suppose you have 2x to the third y times 3x to the negative fifth y squared times 4x to the third y to the negative eighth. If we were going to multiply all these, we're going to group things that are alike. I can see I have 2, 3, and 4 are like coefficients. They go in front. So I'm going to multiply 2 times 3 times 4. Multiplication is commutative. That means I can change it around as long as we're multiplying. Alright, the next things I'm going to identify is my x's. And I see I've got 3, so I'm going to write those as x to the third times x to the negative fifth times x to the third. And finally, I'm going to identify my y's. And I have y to the first, because this is a 1, times y to the second times y to the negative 8. Now, if I multiply the front, 2 times 3 times 4, 2 times 3 is 6 times 4 is 24. I add the exponents. 3 and 3 is 6, and 6 minus 5 is 1, so x to the first. And I add these exponents. 1 plus 2 is 3, plus negative 8 is negative 5. So now I look at that, that's my answer, but I'm going to write it without negative exponents. Here's the negative exponent, so that's going to go down. So I have 24x over y to the fifth. Finally, with last night's homework, you had one more question. Suppose you have c to the third times c to the fourth to the negative second. If you remember PEMDAS, we're going to do our exponents first. So we're firstly going to remember to multiply power to a power. So 4 times negative 2 is negative 8. Now we're multiplying, so we add exponents. So c to the 3 plus negative 8 gives me c to the negative fifth, which is 1 over c to the fifth. So those are some problems. I hope that helps you. And if you have any questions, email me or give me a call.